So far, we have learned about RFlex. From this lecture, I will introduce RFlex, that is, reduced flex. First, let's take a look at the overview of RFlex. RFlex is a flexible body simulation method using modal superposition. As you can see, the deformation of a body is expressed by superposition of several modes. RecurDyn uses modal analysis results using CMS method. RFlex calculates much less DOFs than Reflex. In addition, if a flexible body is expressed only with the limited number of modes, the degrees of freedom can be smaller. As a result, the calculation time is much faster than Reflex. It is suitable for the large models with much more nodes and elements than Reflex. However, RFlex is based on linear approach, so there are some limitations. For example, the deformation must be small, only elastic behavior can be considered, the load point must not change. I will show you the typical RFlex simulation process with this suspension model. First, I will convert this Reflex body to an RFlex body using GManager. Modal analysis must be performed using RFlex Gen, which will be explained later. Select the nodes which are connected to joints and bushing forces as interface nodes and run a simulation. RefleX body is replaced with RFlex body as soon as an RFI file is created by RFlex Gen. The various modes, which are the results of modal analysis, can be visually checked in the body dialog box. Now, after simulating this RFlex body model, post-processing such as contour plot can be used like RefleX. In the introduction and demo videos, I mentioned mode or modal analysis several times. The modal analysis means the calculation of the modes of a flexible body using eigenvalue analysis. Eigenvalue analysis allows you to obtain eigenvalues and eigenvectors. A mode shape, which is a kind of shape of the vibration, can be obtained from the eigenvector. From the eigenvalue, the frequency of the mode shape can be obtained. RFlex represents the deformation of the flexible body through the superposition of these modes and the contribution of each mode. There are two types of modes, normal mode and constraint mode. I mentioned that RecurDyn uses modal analysis using CMS method. This CMS method is able to calculate the constraint mode as well as the normal mode. Normal mode is a mode calculated without any boundary condition or constraint on the flexible body. Each mode consists of a deformable shape of the body, that is, the mode shape and frequency of the mode shape. RecurDyn will use as many normal modes as you set for simulation. Constraint mode is a mode when specific nodes are constrained. This constraint mode is essential when the RFlex body is used with joints, forces, so forth. In the image on the right, the left side is fixed and the downward force is applied to the right side. Therefore, constraint mode with the fixed left side and a constraint mode with the constrained right side must be included to simulate this model. Constraint mode is essential when defining joint and force. When running a modal analysis in RecurDyn, users need to define interface nodes in advance, and then constraint modes are calculated. This is the dialog box of RFlex Gen, and the interface nodes can be set using this section. Here, interface node means the node where a joint or force is attached or will be attached. Usually, master nodes of FDRs are used as interface nodes. Each interface node can have up to 6 constraint modes. RFI files should be explained also. RFI file is an abbreviation for RFlex interface file. This file contains information to create an RFlex body such as mesh and mode information. The RFlex body is created by importing an RFI file into RecurDyn. In order to use RFlex, the corresponding RFI file must always exist even after importing it. If the RFI file is missing, the RFlex body cannot be used. There are 3 ways to create an RFI file. First, it is created using RFlex Gen function. Second, you can export an RFI file directly from other FEA software, NX-Nastran and Altair's OptiStruct. Third, you can create an RFI file in RecurDyn using the modal analysis results calculated by other FEA software. Please refer to the RecurDyn manual for the details. A typical RFlex simulation process is as follows. First, create an RFI file and import it to create an RFlex body. After that, define joint, force, contact, and so forth to the body. Then run a simulation. Like Reflex, you can view strain and stress through animation and plot as well as contour plot. At this time, using the G-modeling technology, it is possible to easily create and import RFI files and preserve defined joints, forces, and contacts. In Reflex, there are 3 modes: assembly mode, Reflex body edit mode, and measure mode. In RFlex, there are just 2 modes. In assembly mode, you can import an RFI, apply load, create joint, force, contact, and do post-processing. In RFlex body edit mode, you can define entities such as set and output. I will end this lecture here and continue it in the next one. After watching all the MFBD kit courses, don't forget to try the workshops in the below link here. Thank you.